So in our previous session, we have seen how to declare an array list and how to add the elements and how to remove and how to perform other methods on array list, linked list, and vector. Now, in today's session, we'll discuss from what is stack. So till now, if you have any doubts, you can ask. Otherwise, we'll go forward. Is my screen visible? Okay.
Yes, ma'am.
Okay. So we'll see what is a stack. Stack is a collection which operates in the form of LIFO. LIFO stands for last in, first out. That means the element which is added at the last, that will be processed first. I can say an example of, I think all of you are aware of idli set. So the element in the stack, this is the stack, only one end will be there. Only one end. From this end only, you will be adding the elements and removing the elements. So you will add elements from this end and you will remove the elements from this end. So the last element which is added, that will be processed first. Suppose I am adding 10, 15, 12 like this. This is the first element, second element, and third element. So first I have added 10, so it will be placed over here, then 15, then 12. So which is the element that is added at the last? 12. So that will be processed first. So in that way, the stack works. The element which is added at the last will be processed first. Idli set is an example. Okay, so we'll see how it works with an example. So these are the methods of a stack. So in order to add element, it is not add, it is push. Push is to add an element to the stack. Pop is to remove an element from the stack. Peek will display the element which is to be next removed or next processed. The element which is going to be processed next, that will be displayed using the peek method. If you want to search for any element in the stack, you can get it using the search method. And if you want to clear the stack, you can use, so if you want to check if the stack is full or empty, so then you can use this method, is empty. Actually, it is empty. It's not empty, it is empty. Okay, so these are the main methods of the stack. Push is to add, pop is to remove, peek is to display which is the next element that is going to be processed. Search is if you want to search for any element in the stack. Is empty is used to verify if the stack is empty or not. It will return a Boolean value. If the stack is empty, it will return true. If the stack is not empty, that means if it contains at least one element, then it will return false. Okay. Now we'll see program for the stack. Sorry. A list of type. So now we'll create a list of type string. Okay. Stack st is equal to new stack of type string. Okay. Let me import these things. Okay. Now, in order to add the elements to the stack, we have a method called st dot. So what it is showing is you can use the add method also, but it is in the list interface. So list interface has these methods, right? Add all these things. But the programs related to stack are, if you go into this program, so if you go into this program, it is extending the vector. So stack is extending vector. Okay. Now in this stack, the methods which are specific to this stack are push, pop, peek, empty, search. So these are the methods that are specific to stack, but it is extending vector as well. That means vector is the superclass and stack is the child. So what and all methods are present in the vector, those can be accessed from stack as well, because stack is extending the vector. So in vector, all the methods are there, right? Like add all those things will be there. But specific methods to the stack are only these five methods, like push, pop, peek, search, and is empty. So these are the methods which are specific to stack. Okay. Now, so st dot, if I try to work with push, okay, it will not show, because using the list object reference, you cannot access the stack specific methods. So using the list object reference, you cannot access the methods which are present in the stack. Stack specific methods will not be able to access, right? So that is the reason it is not showing the peek method. So what you have to do, you have to create an object for stack itself, not the object reference. Okay. Now, if you try to access the methods peek, it will be shown. Or suppose first you need to do this push operation. So I want to add string elements. String. This is the first string that I want to add. Now, st dot push. So you can do all this using add also, because stack is extending vector. So you can use add method as well. But I want to show you the stack specific methods. Add we have already seen, add all we have already seen, all those things we have already seen. But let us see some methods which are specific to these collection types. Okay. Okay, I added 4 elements to this string. Now what we can do? We can push, we can peek, we can search, and we can check if the stack is empty or not. So let's see one by one. So first, let me display the elements what are available in the stack. So if I use the system.out.println of st, okay, this Vasvik, Shivan, Shurnavi, and Varshini. So these are the elements which are present in the stack. Now let's see what is pop. Can somebody tell me, when I use pop, pop method is to remove an element from the stack. Which element will be removed? If I use the statement like this, st dot pop, which element from this stack will be removed? Can someone give a try? Pop is to remove an element from the stack. So which element will be removed? We already know what is how the stack operates. The element which is added at the last will be processed first, right? So now if I use the pop method for this stack, it has to remove one element. Which is the element that will be removed from this stack? Can somebody try that one? Saujanya, can you try? Sorry. So what is that last element here? Oh, yes. So I use the pop now. Let me display the content now. This, if I use this one, stack elements after pop. Okay. ST. Okay. So it got removed. The last element got removed from the stack. Okay. This is how it will work. Stack will work. Now, if you want to search for a particular element, it will return the index. So system.out.println searching for, okay, so let me st dot search, okay, let me save this one, run this program. Yes. What is this one? Can somebody tell me what is this one? So one means,
One element.
sorry,
One. Actually, we are searching for Yognavi, right?
uh,
So it gives the one element, one name,
one name. That means the number of
string,
occurrence,
one string. We are
once,
searching for the one string.
okay. Suppose I have one more string like this, one more element. So stack will allow the duplicates. So I added two elements with the same string. So line number 13 is adding Yognavi and line number 14 is also adding Yognavi. Now, if I run this program, still it is one. You have two strings with the same name, but still it is displaying as one.
Yes.
Okay. Now, if I search with some other string like this, now can you tell me the output? The output will be 3. Let me show you. Yes, the output will be 3. Actually, the ordering, how it will happen in a stack is the element which is added at the last, that will be considered as 1. This is 2. This is 3. The reverse ordering will be there. The numbering will be in this format. It will not take the indexing starting from 0, 1 to the element which is added first does not have the priority, right? So the element which is added at the last, for that it will give the index as 1. This is the first element to be processed. This is the second element to be processed. This is the third element to be processed. Same way, now in our stack, we have 4 elements like this. So this is the first, this is the last first element which we added. So it will have the least priority. Whereas the element which we added last, so Yognavi, this one will have the highest priority. So that when you search for that one, it will return the index of that. So here in stack, the indexing will be in a reverse order. The last element will have the high priority. So that will be the first one. So the index 1, the indexing in stack, it will start from 1. So it will be in the from top to bottom, not from the element which is added first. It will be in the reverse order. Okay. So now if you give Yognavi, so it will show you it is the first element which has the priority, highest priority. Okay. So that is what it has displayed here. Now, if you work with peak, the peak will be the element which shows you the next element to be processed. Okay. So the next element that is to be processed is st.peak. Can someone tell me what will be the output here at line number 25? Line number 25. So the next element which has to be processed will be displayed by peak. Okay. So now what is the next element that has to be processed?
Varshi.
Yes. Oh, sorry. It is removed, right? We removed it using st.pop. See, these are the elements. This is the first added element, second element, third element, and fourth element is this one, right? Initially what we added, but we removed last element. We used the pop method. That means this element will be removed. Now we have only these three elements. After this, I have added one more element like this. Now we have four elements, right? In these four elements, if I use peak, what will be the element that will be displayed? This element is not available. We used pop and it is not available. So it won't be there. The stack doesn't contain this element if you use pop. So this element is removed. So the next element is this one, Yognavi. So when you use this method peak, it will display Yognavi.
Yes, yes.
Now if I run this program, it is displayed like this. Now I'm using st.clear. Okay. Search. And now if I want to check, is the stack empty? Empty. st dot is empty. Yes, it is empty. It returned true because I cleared all the elements. Before this, if I want to check, before clear, is the stack empty? Okay. If I want to check this one, st dot is empty. Okay. Let me run. Before emptying, it is before clearing, it is not empty. After clear, it is empty. So these are the methods that are specific to stack, and this is how we use those methods to perform certain operations on the stack. So you can either use this add method, add all, so all will be applicable for ST also. All will be applicable for this stack because stack is extending vector. All the methods which are present in vector can also be accessed using this stack object. Okay. So all the common methods. So what are the methods that are common that can also be accessed using this ST? Okay. One thing I forgot to discuss, so we'll discuss in the array list. So if you want to iterate through elements, so the way you added it, it is iterator. But if you want to display the elements in the reverse order, so see here, it will display in the order of how you added. So iterator will display the results in the order how you added elements to the list, right? So if you run this program, so this is ArrayList demo program, okay, previously which we worked. So how it will display the elements? So it will display the elements in the order how you added. So first you added 10, then 15, then 12, then 13, then 25. In the same order, it will display your output. But I want to display the results in the reverse order. That means the last added element should be displayed first. So in that order, if I want to display the results, you can do that. iterate in reverse order. Okay, if you want to do that, you have an class called list iterator. See, you have a this thing called list iterator of type integer lit. List iterator is equal to al dot list iterator of, you have to give, the difference is here you have to give the size of the array list. So you have to give the size of the array list. You have to pass it, otherwise it won't accept. So this is the syntax of, so how to declare a list iterator. Okay. So we are done with it. And now we want to iterate through the element. So using the while loop, lit dot. So if it has, if you are searching, if you are iterating from beginning, you will search if the array list has next element or not. But you want to search in the you want to display in the reverse order, right? So you have to use the method has previous. So in the forward direction, if you want to go, you will use this method has next. In the reverse way, if you want to display, you will check if it has previous element or not, if it has previous element or not. So if you use this al dot size, it will point to the last element of the array list. Last element of the array list. First, initially, the last element will be pointed, and then it will check if the previous element is available or not. So this is how, so first it will point to the last element like this. So it will check if if it has next element or not, if it has previous element or not. So like this, in the reverse way it will go. Okay. So we use the method has previous. If it has previous, system dot out dot println lit dot next. No, sorry. We have this method lit dot previous. If you save this one, let me differentiate this too. Save it. Now, if you run this program, see, it displayed the results in reverse order 25, 13, 12, 15, and 10. So it displayed the results in the reverse order. So in both the directions, you can navigate either from beginning to end or from end to beginning. Okay, this one I missed. So this is about the list collection. So if you have any doubts, you can ask. I'll show one more example for linked for remove if. I want to show one more example. So all this I have done using the strings, sorry, integers. I'll create one more using the strings, okay? Class ArrayList string demo. Using the strings, I'll create one more ArrayList. ArrayList of type string. I'll add few strings here. Okay. Now I want to perform remove it. So I'll show the list iterator here as well. So let me write that list iterator so that for taking this, it will be easy. New list iterator. Sorry, not this one. What is this? Li dot list iterator of li dot size here. Okay. While loop lit dot as previous, then system dot out dot println lit dot previous. Okay. So it will display all the elements in the reverse order. So let me run this one and show. So the last element is displayed first. First element is displayed last. Now, I want to show one more example for remove if. So based on some condition, it will remove the elements from the array list, right? So li dot remove if. Here you have to add a predicate. That means a condition you need to add. So x such that x dot. So whatever string operations you can do. So you can work on that. So I want to delete, remove the elements from this collection where it contains, if it contains the character V, all those elements I want to remove. So I think all the words contain V. Okay, let me check. If X contains this character, I want to remove it. It should be a string. Okay, I want to remove this. Now after this, I want to check what are the elements of the collection system.out.println li display it. If I run this program, the only, because the first word contains V, second word contains V, third one also contains V, fourth one doesn't contain small letter V. So it will check, it is case sensitive. So it will check only for that one, only small letter V. If it is available in that string will be removed. Otherwise, it will be available in the array list. So using strings, you can perform the remove if. So you can use all the string related operations. So like contains, ends with, or is blank, or matching with character at, based on, so what and all the methods available for string operations. So you can use all those that the methods that returns true or false. So this predicate means it is a condition. It has to remove, it has to return either true or false. So all such methods you can use. The methods which will return either true or false regarding to strings, all those methods you can use as a condition in this remove if. Clear all of you? All of you, is it clear?
Yes.
Okay, this is one thing. Now we'll go to the next concept. This is about list. The next concept is map. But before going to map, we want to learn about what is hash code and how it will be generated uniquely for every object and every string, how they got the concept of hash code. Okay, and what is this equals method? So these two things we need to understand very clearly before going to map, because in map everything works using the hash code. Okay, so we'll understand first what is hash code and how it is generated. Okay, and what about this equals method? Hash code. First of all, what is hashing? What is hashing? Hash, why we need to go for hash code generation. For an object or for a string, why we need to generate a hash code? What is this hash code? It is an integer, unique integer. For any object, hashing means converting either an object or a string or whatever it might be. So left hand side may be anything. It can be an object or it can be a string, whatever it might be. You are converting it into equivalent integer, unique integer. This is called hashing. Hashing means converting an object or a string or whatever it might be. If you are converting it into an integer, then we call it as hashing. Hashing means converting one type to an integer, unique integer. So this will be unique for every object, like similar to Aadhaar in India. Aadhaar number is unique for every individual. So the same way, either an object or a string or whatever it might be, we are giving a unique integer for it. So that process we call it as hashing. So why we need to do all these things, we will see. This object or string, so it is for memory optimization. Why we need to convert it? For memory optimization and easy access. So on integer, we can perform whatever we want easily. So integers are more flexible in order to perform any operation when compared with object or string, whatever it might be. So that is the second reason why we do the conversion. And memory also, for the memory allocation, so it will allow you to occupy less space when compared with others. So integers will take less memory when compared with either objects or strings. So for memory optimization, we do this one, and for easily accessing. So if you want to access get the details of any person, you can get it simply by using the other, whatever they have done, everything. So it will be easy when compared with the names or surnames or other details. Aadhaar will be easy. So that is the first reason why we convert all these things to integers. And even memory optimization also will be less, like the consumption of memory will be less for integers when compared with objects or strings. So that is the one more reason why we do this hashing concept. Now, how we can convert it? First, when they came up with the hashing, so we need this conversion. The first thought was, suppose I have a string like this. I have a string like this. I have a string like this. Now, initial idea of how to convert this to integer was, we have ASCII codes, right? ASCII codes for each and every character on the keyboard. We have an unique integer. So for we have an ASCII code. Suppose I'm writing for example, okay, not the exact ones. First, for capital V, we have one ASCII code. Suppose 101. For small a, we have one ASCII code 99. So whatever integer ASCII codes we have, we will write all those ASCII codes for these characters. Okay, for R it might be 120 or something like that. 121 like this. 114, 101, 101, and for N 99 some. So I wrote a randomly like this. What they did was they added all these things. They added all these things like this. And finally, you will get with an output. Suppose 2012 like this, 22 like this. I am writing the random numbers. Don't fix it as confirmed. Okay. So this is how for a particular string, they generated an integer and they called it as hash code. This is the hash code of the string. This is the first version. But if I use this logic to convert a string to an integer, then what will be the ASCII code for this string? For this string, what will be the ASCII, what will be the hash code? Can someone tell me? I use the same letters which are available here. I use the same letters, but arrangement of that letters is different. All the characters which are present in the first string are also present in the second string, but arrangement is different. So for R, it is 120. For S, it is 121. For V, it is 101. For A, it is 99. For N, it is 99. For I, it is 101. For H, it is 114. And for I, it is 101. Again. Now, if I add all this, add all this, it will return me to 122. But it is not unique. So these two strings, the strings are different, right? But the characters in it are same. But strings are, these are two different words. The first is Varshini, the second is some other word, RSVANIHI. This is different word. Here, two different words are giving me the same hash code, which is contradictory. Hash code means it should generate a unique integer. It should not generate same integers. So this concept has been violated. It is so they came up first with this idea of generating the hash code, but this got failed when two different strings with the same characters are trying to generate an hash code. So these are two different strings. If I want to generate a unique hash code for these two different strings, but this logic failed in this case. So the next idea what they got was they multiplied with a particular factor. So each integers, they multiplied with particular factor. So for V, this is the ASCII code, right? 101. For this, they multiplied with a particular factor. What is that factor? Suppose 1, 2, 3, 4, 5, 6, 7, 8. The length of this string is 8. Okay. Now they multiplied this each and every ASCII code of these characters with 32 to the power of length minus 1. Sorry, n minus 1. Sorry, let me tell you. So let me write it clearly here. This is V A R S H I N I. Length is equal to 8. And these are the ASCII codes. Let me write some integers. I'm randomly writing some integers. This is the length. They tried adding the they tried with multiplying with a particular multiplying factor. Okay, so that is 32 to the power of I can say like length minus index. Okay, the index of this one is, so what is the index? This is 0th index, first index, second index, third index, fourth, fifth, sixth, and seventh. 30 to the power of length minus index means 101 into 32 to the power of, what is the length? 8. 8 minus index is 8 minus 0. That means 8. 8 minus 0, which is equal to 8. And now The addition will be the same. The addition will be the same. They are adding it. But before adding, they multiplied with a particular factor, which is 32 to the power of length minus index. Okay. Now 99. The next character is A, whose ASCII code is 99. And to this 99, we are having the multiplication factor, which is 32 to the power of length minus index. So the index of A is 1 and the length of this string is 8. So 8 minus 1 is 7. So they multiplied this with 32 to the power of 7 plus the index of R is 2. So 32 to the power of 8 minus 2, which means 6. So they multiplied with 32 to the power of 6. The same way with S, the index of S is 3. They multiplied with 32 to the power of 8 minus 3, which is 5. 32 to the power of 5. This will be 32 to the power of 4. This will be 32 to the power of 3. This will be 32 square and this will be 32. Clear all of you? Now it will generate some random number, random integer, which is, for example, 1, 2, 4, 5, 6, 8, 2, 0, 0, 1, like this. It generated some random integer. Now, if I take another string using the same characters here, so R, let me remove this one. The multiplying factor will be the same, okay? It will be 32 to the power of length minus index. Okay, R, S, H, I, A, B, which is pending, I, N. Okay, suppose the ASCII code of R is 101 and for S it is 200, for H it is 40, for I it is 55, for A it is 99, for V it is 101, 55, and for N it is 12. Now the multiplying factor will differ, right? For R it is 10. So multiplying factor for R will be 32 to the power of 8 plus for S, in the previous example, it was 32 to the power of 5 for this word. But for here, it will be 32 to the power of 7. This will be multiplied with 200 and it will be added like this. So for H, previously it was 32 to the power of 4. Here it will be 32 to the power of 6. For I, it will be 32 to the power of 5. And in the previous example, it is 32 cube and 32. So this is how it will vary. And now this will generate a unique hash code. This will generate a unique hash code. This is the concept of hash code, how they generate the hash code. This is the internal logic. Whenever you use the method object dot hash code, it will generate a unique integer, right? So behind that, the logic which they have implemented is this one. So they'll write the ASCII code of that particular character and they'll multiply it with 32 to the power of length minus index. So this is the concept which they have used to generate a unique hash code. Using this method, I cannot say 100%, I can guarantee that 99% it will generate a unique hash code, because there are strings which even today, even now, we get the same hash codes. I'll show you that one as well. So using this technique, 99% you can get unique hash code, unique integer, not 100%, only 99%. We can guarantee that using this technique, you can get unique integer. Is this concept clear how they are generating? So this is internal logic what they have used. If you want to create your own hash code, if you want to write the code for generating hash code, you can write it. So it is up to you. If you want to use already existing one, it is the hash code method is available in the object class, which is the super class of all the classes. So in object class, you will have a method to generate the hash code. So in this, they have used the logic like this. But if you want to override this hash code, you can write it, overwrite it, and write your own logic to generate the hash code. You can write your own hash code. You can write your own logic for generating the hash code. Okay, it is not mandatory that you have to use only this method to generate the hash code, because it is only 99% they can guarantee you that it will generate the hash code. But there are cases where this also will fail. So one such example is capital A and A. This is one string and this is another string. For these two strings, if I want to generate a hash code, okay, so let me try. I'll try to generate the hash code. For capital A, sorry, for capital A, it is 65, right? 65. For capital B, it will be 66. For small a, it is 97. It will be into 32 plus 32 square. So this is 32 square. Sorry, this is into, let me differentiate. If you do the output of this, it will be 2112, and this also will be 2112. That means these two strings are generating the same hash code. If you generate, I'll show you in program as well. So the hash code of these two strings, capital A, small a, and capital B, the hash code for these two strings will be the same. But are these two unique? This is not the unique hash code, right? These two strings. So if hash code is same, means the two strings should be the same. But here these two are not same. For different strings, the hash code generated is the same in this example. That means for different strings also, hash code is not same, which is violating our rule. What is our rule? For different strings, different hash code should be generated. So whatever logic they have implemented to generate hash code failed in this case. The second attempt also failed. Okay. So what they came up next is they generated equals method. Equals method. If so, what does this say is, if the hash code of two different strings are matching, so hash code for AA and hash code of BB is matching, but the strings are different, right? So the strings are different, but still the hash code generated is same. So in that case, what this equals method do is, if the hash code is same, it will check the content of the strings. So what is the content in this string and what is the content in this string? So the content in first string is AA and the content in the second string is BB. So it will check the content. So it will check if AA characters, so the characters in the first string are equal to the characters in the second string or not. If they are equal, if the content is equal, then only we say that the two strings are equal, are matching. Otherwise, if the content is not same, then even though if the hash code is same, then the strings are not equal. So the content in AA and content in BB is different. Though, so finally, the result will be after using the equals method, the result will be like the two strings are not same, or the two objects are not same, even if the hash code is same. So I'm writing this condition after the hash code is same. So the hash code of two strings is same. So after that, we need to do one more check, that if the content in these two strings are equal or not. If the content in these two strings are not equal, then we say that two strings are not same. Else, if the content is also same and the hash code is same, then no problem. The two, we can finally declare that the two strings are same. For same strings, the hash code will be same and the content will also be same. Suppose I'm trying to check AA with AA, if these two strings are equal or not. First, what it will do, it will generate hash code for this one and it will generate hash code for this one. It will check if the hash codes are equal. Yes, if the hash codes are equal, both will generate an hash code of 2112 and 2112. It will not leave it just like this here. It will check the content now. The content in first string, if it is equal to the content in the second string. So once the content is same, then only we can declare that these two strings are two different, two objects are same. Otherwise, so in this case, it is, we are trying to check AA if it is equal to BB. The first it will check the hash code. So hash code for these two is same, but we cannot declare that these two strings are equal at this point itself, because even though hash code is same, we have to check the content. So the content in AA is different from content in BB. So even though if the hash code is same, it will not say that these two strings are equal. Hash code generated is same, but these two strings are different. So in order to differentiate that, they came up with this method, equals method, in order to check the content. So equals method will check the content of two strings or two objects. So that is why hash code will always come with equals method. Hash code method will always comes with equals method. Only just this hash code is not enough for us to say that the strings are equal or not. We have to combine it with equals method in order to say that two strings are equal or two strings are not equal. So if you want to compare two different strings or two different objects, first thing what it will do is it will first generate the hash code. So 99% it will generate uniquely. 99% of the strings, the hash code generated will be unique. But for the remaining 1%, where this hash code generation fails, in that case, they came up with this equals method. So this equals method, what it does is, even though the two strings are different, and the hash code generated is same. The same hash code is generated for two different strings. In that case, it will check the content of the strings, content of the whatever is present in the string, that content will be checked. So that is the reason why hash code will come with along with equals. They are not separate methods. They always come together. Hash code will generate an integer and equals method will check the content of that string. Is it clear, all of you? All of you?
Yes, ma'am.
Okay. So now one small example we will see for generating the hash code. Okay. Let me take a string x is equal to a. Okay. Now string y is equal to bb. Now I want to generate the hash code for these two. System.out.println The hash code for X is X dot hash code plus the hash code of Y is plus Y dot hash code. Okay. So let me run the program. Generally, ideally, the hash code generated should be unique. It should not be same for two different strings. But in this case, the hash code generated will be same. The strings are different, but hash code generated is same. Same hash code is generated. So in this case, what they will do, we will we will use the equals method. What equals method will do, it will compare the content of the strings as well. Okay. Now let me run this program. See, for X, it is 2112, and for Y also the generated hash code is 2112. If these hash codes are same, right? But what does this string does? We have to use the equals method. If X dot equals of this object Y, then we should use both the strings are equal. Otherwise, okay, let me run this program. The strings are different. So this is how we have to check if the two strings or two objects are equal or not. So we cannot blindly depend on the hash code. So 99% it will generate a unique value. But in other rest of the cases, we have to use this equals method. In the next session, we will see what is in this equals method and what is the difference between the hash code generation of a string and hash code generation of an object. So we will see all those things in even in more detail in the next session. Okay. So till now, so this today's is a theoretical session of what is hash code and how we can generate, what is the internal logic they have used. And we will see in tomorrow's session how we can generate our own hash code in our program. So if you want to generate if you want to write a logic for hash code generation, you can write your own thing. So we will see even that as well, and why this and how this helps in hash map. So how hash map uses the concept of this hash code generation and how it uses the equals method. So we will see in more in detail in next session.